Okay, so I decided to make a bonus video on completing the square. Last class, someone had asked me to solve a few problems from the section 2.3 worksheet, numbers 7, 8, and 9. Those are the problems all having to do with completing the square. I didn't have time to do them in class, so I made you a little video. So we have f of x equals x squared minus 14x plus 24. And we want to find the zeros of this polynomial by completing the square. So I have to set this equal to 0. That's our first step for completing the square. The next thing I want to do is I need to go ahead and move 24 to the other side. So I've got x squared minus 14x equals 24. Now here's the key for completing the square. What I want to do is add my middle term, b, divided by 2 squared, because that'll allow this to perfectly factor to x plus b over 2 squared. So I'm going to take negative 14 divided by 2 squared and add that to both sides. That's going to give me x squared minus 14x plus 49 equals negative 24 plus 49. So this left-hand side is going to factor to x minus 7, because negative 14 divided by 2 is b divided by 2 squared, which equals negative 24 plus 49, which is 25. I then go ahead and take the square root of both sides using the square root property. That gives me x minus 7 equals plus or minus 5. So in order to solve for the two zeros of this equation, I take x minus 7 equals a positive 5, and x minus 7 equals a negative 5, and then I add 5 to both sides. I add 7 to both sides, not 5, 7. Good grief. So that gives me x equals 12 and x equals a positive 2. Okay, so these two solutions, okay, these are sometimes called our zeros. These are our real zeros. You could also say there are solutions. Some people call them the x-intercepts. That's because that's what they are. And it's when x is 12 and x is 2 that y is 0. So let's write it as an ordered pair. So I've got when x is 12, y is 0, and when x is 2, y is 0. Those are our x-intercepts, real zeros, solutions, etc. Arose by any other name, right? Let's take a look at this next example. I have x squared plus 6x minus 40. I do the same thing we did before. Set it equal to 0. Move the 40 over to the other side and add my middle term divided by 2 squared. That gives me 40 plus 9, x squared plus 6x plus 9, which factors perfectly to x plus 3 squared equals 49. Then again, I use the square root property. I get x plus 3 equals plus or minus 7. X plus 3 equals a positive 7. X plus 3 equals a negative 7. So I subtract 3. So that'll give me x is 4 and x equals negative 10. Those are our real zeros, x-intercepts, solutions when x is 4 and when x is negative 10. And if you were to say go to Desmos, which I highly recommend because you know me, I love some Desmos, you would graph this polynomial and see, these two x values is where our graph crosses the x-axis. It's so exciting. Go take a look. I hope you like it. Now, here's when things get more complicated. Completing the square only works when my a term is 1. So in order to solve this, it gets a little messy because fractions, but we know what we're doing. We're experts, we got this. I have to divide by 25. Why? Because we need that leading term to be 1. So that gives me x squared plus 30 over 25 x plus 8 over 25 equals 0. So I have x squared equals 6/5 because in this class we simplify our fractions, as you should in all fractions in all classes, equals nope, not equals, gotta give myself some space, a negative 8/25. We've got to move that to the other side. Then I add my b term divided by 2. I've got 6 divided by 5, so 6/5 divided by 2 squared. So we can take this a step at a time. 6/5 divided by 2, that will give you 6/10. So my left-hand side simplifies to x plus 6/10 squared. That equals negative 8/25 plus 6/10 squared. That's going to give me x plus 6/10 squared equals negative 8/25 plus 9/5, 9/25, because 6/10 that simplifies to 3/5. 3/5 squared gives us 9/25. So I have x plus 6/10 squared equals 1/25. We still use the square root property to take the square root of both sides, but maybe we should go ahead and rewrite 6/10 as 3/5, just for clarity and simplicity. So x plus 3/5 equals the square root of 1, which is 1, or the square root of 25, which is 5, plus or minus. So I get x plus 3/5 equals 1/5, and x plus 3/5 equals negative 1/5. So I subtract 3/5 from both sides. I find that x equals negative 2/5 and x equals negative 4/5. And those are our two real zeros. So again, these were questions 7, 8, and 9 from worksheet 2.3. If you have any questions, please let me know.